Hi everyone, welcome to the second lesson for topic 4.2 loans, investment and annuities. For today's lesson, we are still under the subtopic for compound interest loans and investment, and there are some new things that we'll be looking at today, which is called as effective annual rate of interest. So you'll be learning what is that meant by this effective annual rate of interest, how to calculate it by using the formula, and then how are you going to use the result so that you can compare the investment return and also the cost of loans when you have different compounding periods for your interest. All right, so you can just remember this word last. So this is the thing that we are going to learn today. All right, so let's start off with the lesson. Alright, in our first lesson, we have discussed the difference between simple interest and compound interest. So for all the cases that we are going to discuss in today's lesson will be based on compound interest. Because for simple interest, the interest that you are generating for each of the compounding period is just going to be the same. So that's why no matter we are talking about the nominal interest rate or effective annual rate of interest, there will just be the same. And there's no point that we want to calculate the effective annual rate of interest. So that's why all the cases that we'll be looking at will be based on compound interest. All right. So the interest rate that normally the bank quoted for a loan or investment is called as the nominal interest rate. So this nominal interest rate is normally the interest rate per annum. So, previously when we are trying to go through all the example, right? So all the interest rate that given to you are nominal interest rate. Okay, so normally, what are the amount of interest that you will be getting after a certain period of time will be depends on two things. So the first one is nominal interest rate and the second one is term. So for example, if let's say we have investment A, which give you a return of 4% per annum, then after that you have investment B that give you a return of 5% per annum, then obviously you are going to choose the second one rather than the first one because you can get a higher return from that, right? So that's the first one. So second one, the term, so which means that, for example, if let's say you have another investment which is like giving you 5% of return per annum as well, okay, but you are putting your money in investment B for 3 years, then you are putting the investment for investment C for 5 years, then definitely the one that you're putting for a longer time is definitely going to give you more interest when you try to compare to the shorter time, which is the 3 year. So that's why normally we know that the amount of interest that you'll get based on these two things, the rate and also the term. Okay. However, based on our example in our first lesson, we also know that this amount of interest will also be affected by the frequency of the compounding period. Okay, so which means that you have this nominal interest rate, but then because of the compounding periods are different, so that's why at the end you are going to get a different amount of interest as well. So we are going to look at this simple example here. Consider the case where we are going to invest 10K in an account that paying 5% per annum for compound interest. So this is the formula that we have learned in during our last lesson regarding compound interest, right? So in this situation, we are going to look at 5 different situations which you have the same nominal interest rate here, which is 5% per annum, but they are going to having different compounding period, which is like annually 1 time in a year, 6 monthly 2 times per year, quarterly 4 times a year, 12 times a year, and also daily. All right, then we are going to look at, is there going to make any difference in the total amount of money that I have in my account after 1 year? Okay, so let's start off with the first one. So we know that to find out the total money here, we are going to use the principal, which is 10K. Okay, multiply by 1 plus, so the R here, the interest rate here is 5%, right? So 0.05. So R is how many times you compound in a year. So annually, meaning 1 year, 1 time. So small n is 1. Then after that, T, we are looking at 1 year, right? So that's why it's 1. So now let's try to put the information in our calculator and try to calculate that. So we have 10,000. Okay, then multiply by 1 plus 0.05. So in this case, over 1 no need lah. So power 1 also is just the same. So as a result, then we can get that after 1 year, you have 10,500 in the account. All right, so that's for compounding period annually. So now let's look at 6 months. So the same thing, the principal is going to be exactly the same. And then 1 plus 0.05 because it's compounded 6 monthly, right? So that's why 2 times in a year. So we will divide by 2, and after that 2 times also 1 year. All right, then from here, same thing. We can try to use our calculator here. So we can straight away change it here. So 0.05 over 2. Okay, and then to the power of 2 as well. So from here, we'll be able to get the total amount of money that in our account will be 10506.25. Okay, so from here, then definitely you can see the difference here already. So although you have like $6.25, but it's still going to be bigger than the first one, right? So I hope that I still remember the thing that we discussed in a previous lesson is because of you compound 2 times in a year. So that's why the second time that when you are calculating the interest, right, is going to base on the principal plus the accumulated interest that you get in the first time. So at the end, the interest that you are generating in the second time, although it's under the same interest rate, but then because of the principal plus the accumulated interest, so that's why the interest in the second time is becoming a greater amount. So that's why you can see that this amount is bigger than this amount. So same thing, let's move on to the next one. So we have 10,000 as well as principal. So 1.0.05, and then quarterly is like 4 times per year, right? So we are looking at 1 year, so 4 times 1. So same thing, let's try to look at our calculator here. So 4 times, so which means this, we are going to change it to 4. Okay, and then power 4 also. So as a result, then you can see that we get 10509.45. 10509.45. So again, so although it's a small difference, but you can see it increases as well because of the same reason, because now you compound 4 times already. So that's why the accumulated interest plus the principal becoming more and more when every time you calculated a new interest. Okay, so same thing for monthly. So 10,000. So 1 plus 0.05 divided by 12. So 12 times 1 year. Okay, so same thing. Let's try to change in our calculator here. So we have 12. So power also 12. Okay, so yeah, you can get the number is even getting a bigger one, 10511.62. Okay, so that's what we have in our calculator. And last but not least, daily. So principal 10K. So 1 plus 0.05. So daily, we are compounding 365 times per year. So that's why 365 multiplied by 1 year. So you compound for 365 times per year. Same thing, let's do in our calculator. So 365, and then, sorry for that, 365. Okay, and then power also 365. So as a result, then you can get 10512.67. Alright, so that's the answer that we get for each of this. Okay, so that's why what you can realize here is that when you try to compare this amount of money with your principal, right, you realize that if let's say the compounding period increases, the money, the interest rate that you are actually, let me try to rephrase my word. Okay, when you try to compare to this, if let's say I were to put, because normally how do we calculate interest rate is by using how much we receive, then after that divide by the principal that you're having, right? So for example, in this case, you can see that for the annually one, then you earn an interest of 500. So which means when you use 500 to divide by 10K, then that's the time that you get 0.05. So that's why the nominal interest rate here is going to be the same with the effective annual rate of interest, because after 1 year, the interest that you get is eventually the 5% that is stated here, right? So that's why the effective annual interest rate here is also 5%. Okay, but when you look at this number, then what do you realize? Although by name, in nominal interest rate, it's stated that is 5% per annum. But actually, after 1 year, how much do you receive? You receive 506.25 as your interest, right? Then when you divide by your principal, then you realize that this amount is actually more than 5%. So in fact, it actually gives you like 5.0625%. Right? So this is why you get this value which is bigger than the 10500 that generated by the 5% here. So similarly, when you try to look at the next one, they'll give you the same thing as well. So you receive a total of 509.45 after 1 year. Sorry, that's 5. Okay, so divide by your principal here, which is 10,000. Then after that, you realize that you can see that when you multiply 100, right, then you get interest rate of actually 5.0945. Okay, so eventually this value is also a value that is bigger than 5. So by using the same idea, I hope that you can see the pattern here already. So this is going to be 5.1162. You can try to calculate in your calculator, it's just the same thing. Okay, so you can see that even though the nominal interest rate is the same, but as the compounding period getting much more frequent, then at the end of the result, the total amount of money that you have after a year is going to be increasing as well if let's say the frequency of the compounding increase. So that actually cause that the money that you're having is actually more than 5% that it is stated here. So that's why this percentage here is called as the effective annual rate of interest. Is the actual rate of interest after you take into account of the nominal interest rate and also the compounding period. Because when we talk about nominal interest rate, it's just like a rate that is given without considering the compounding period part. So it's just like a interest rate by name. So that's why for this thing, right, then you can imagine if let's say you are borrowing a loan from the bank or you are investing something, it's important for you to know that whether the interest rate that they are trying to tell you, is it the nominal interest rate or the effective annual rate of interest? Because that's going to make the difference if let's say the compounding period is different. Okay, so that's why do we need this? Because effective annual rate of interest can help us to compare the interest paid on the loan or investment with the same nominal annual rate of interest, but then you have different compounding periods. So from here, after you calculate, I mean, of course, in this case, we are investigating on an account of 10K. But then in most of the cases, maybe you do not know what's the principal, right? Then you cannot every time, if let's say you want 5,000, then you calculate it like this. Then if you want like 20,000, then you calculate it again like this. So that's why, how are we going to compare them onto the same page is to find out what's the effective annual rate of interest if you are getting like different option. Okay. So in this case, we are looking at the part where you have the same nominal interest rate and different compounding period. Then of course you can see the more frequent that you compound the interest, then the money that you get after 1 year is going to be higher. Your effective annual rate of interest is going to be higher. Later in the example, we are going to look at you have different nominal rate of interest, but they are very close to each other and their compounding period is different. So in that case, then it will be important for you to find out the effective annual rate of interest so you know that which one give you the higher return. Alright, okay, so now we are going to generate the formula from what we have done here as well. So what you can realize here is that when we are trying to calculate the total amount of money, right, actually we are doing what is the rate that we multiply and then plus the original value. Am I right? So that's why what you can try to see here is after 1 year is like 1. So that's why at the end you are actually just multiplying by 1, 2, 4, 12, and then 3, 6, 5, and so on. So the formula for us to calculate the effective annual rate of interest is, so normally we can try to write like this. So this is the short form that given in your in the formula that will be given in your examination as well. So how do we calculate this? It's definitely the same thing like how do we calculate this. So you will be using 1 plus, and then the R here is your nominal interest rate, and you are going to divide by how many times you compound in a year. Okay, how many times you compound in a year? So if the number of compounding periods per annum is n, then after that you are going to multiply with power n. So why you doesn't have a T here? Because we are talking about effective annual rate of interest, right? We are looking at 1 year. So you can see here all 111. So I mean n multiplied by 1, you are still getting n. So that's why we doesn't need that. But then this is the amount that we are using to calculate the total amount of money. It's not the interest only. So what do we need to do? We need to minus off the original 100% of the principal. So that's why minus 1. So this is the formula that we'll be using to calculate the effective annual rate of interest. So you can try to write down here. So I effective here stand for the effective annual rate of interest. Annual rate of interest. Oh yeah, I think in here they try to use another different. So this is the one. I'm sorry, we might need to change this. So this is I. Okay, same thing. We try to follow what is given in your examination formula sheet. Okay, so the I effective is the effective annual rate of interest. The I here is your normal nominal interest rate. Okay, so same thing as well for this nominal interest rate. When you are calculating it, you must make sure that it's in decimal also lah. So actually what happened as a result here, after you calculate this number, right, this is in decimal also. So after you use this formula, then you need to multiply 100% again so that you get your interest rate in percentage form. Alright, then last but not least, this is like the number of times compounding per year. Okay, so I think this is very straightforward and we are just going to look at one simple example. So to apply the formula here, and from there, I hope that you can understand why are we doing this, and also how are you going to compare by using this effective annual rate of interest. Alright, example, Liana is looking to invest her money. So she has done some research and found the best offer from 3 different banks. So you have different nominal interest rate with different compounding period. So that's why for these cases, it will be a little bit hard for us to, to look at the interest rate and to tell which one is better. Because if let's say you say that the frequency for daily is bigger, but then the nominal rate is lower, but then if let's say you say that the nominal rate is higher, but then the compounding period is actually lesser. So in this case, then what do we need to do is to find the effective annual rate of interest. So to find out which is the one that giving us the best return when we try to invest in that particular bank. Alright, so we start from bank 1. Okay, so perhaps you can try to write down our formula here, then it will be easier for us. So I effective. Okay, sometimes you'll see they just write EFF lah, that's okay as well, but yeah, I mean we just follow the syllabus what is given. So 1 plus I over n and then power n minus 1. Alright, so let's start with our calculation. So for bank 1, the effective annual rate of interest will be equal to 1 plus, so the I here, the nominal interest rate is 8.45, but remember that is in percentage, so that's why we need to change it to decimal. 0.08, yeah, sorry for that. Here's 0.0845. Right, so it's compounded daily, so that's why the n here is 365 times per year. So 365 here as well, then minus 1. Okay, so let's use our calculator to do the calculation. So from here, then you'll be able to see 1 plus 0.0845 divided by 365, and then to the power of 365. Alright, then minus 1. So as a result, then you'll be able to get 0.881622 and so on. Okay, so let's try to write down our answer here. 0.0881622. Alright, then from here, then we can get that the effective annual rate of interest here, so multiply by 100%, then you'll be able to get 8.81. Okay, so round off 8.82% per annum. Alright, so you should realize that after you get the answer, it should be a number that is very near to the nominal interest rate. So normally the difference wouldn't be like that, that distant. So if let's say you get like 8.45% for the nominal interest rate, then you realize that the effective annual interest rate go up to like 10 plus or 12, something like that, then you might need to check out everything again. Okay, because the compounding period, that makes changes, but then it wouldn't like make your answer to be like a very different one. So for example, you can see that all the different period here. So although it's getting higher, but the difference here is actually not too big. Yeah, so normally that would be the case. Okay, so 8.82 is actually quite near to 8.45. Okay, so now we move on to bank 2. Same thing, let's calculate the effective annual rate of interest. So equal to 1 plus, in this case is 8.6%, so 0.086, compounded monthly, so 12 times per year, so 12 and then minus 1. Okay, so similarly, just key in that in our calculator. So 1 plus 0.086 over 12. Okay, answer power 12 and minus 1. So from here we can get our answer 0.0894721. Okay, so 0.08974. Yeah. Okay, so still run it off to the nearest, two decimal places. So we can have 8.95%. Okay, so that's why in this case, then you can see that for this, although this is monthly, this is daily, but because of this nominal interest rate is higher, so that's why at the end, this is going to be higher than this one. Okay, but if let's say you didn't do this, then when you try to compare to the period and interest rate, it's hard for you to justify. So now the last one, bank 3. So effective annual interest rate here is equal to, okay, so 1 plus, so the nominal interest rate here is 8.7, so 0.087. So it's compounded 6 monthly, so 2 times per year, divide by 2, power 2 minus 1. Okay, so same thing, calculator. So 1 plus 0.087 over 2, answers square, okay, and then minus 1. So from here, then I can get my answer here, 0.0888923 and so on. Okay, so yeah, that's our answer, right? Then after that, same thing, try to round it off to the percentage. So it will give us 8.89% per annum. Alright, so what can you realize here is that you see, although this one is having the highest nominal interest rate, and although this one is having the highest frequency, but at the end, it's actually the bank 2 is having the highest effective annual rate of interest. So that's why it's in a case where you consider both nominal interest rate and also the compounding period. Alright, so in this case, then as a result, so Liana should choose bank 2. Okay, so as it provides the highest effective annual rate of interest. Alright, so that's the idea. Okay, so we have only one example here because the key point here is for you to understand how to calculate the effective annual rate of interest. Then, after you understand it, then basically that's the idea for this lesson already. Alright, so spend some time to go through the question. Also, you only have like 2 or 3 questions for this particular lesson. Then after you have understand all this, then you can move on to the next video. Alright, so thanks for watching.